Okay, so 15.4 is applications of double integrals. And these are those, so the first one is something that you've already done, and that is moments and centers of mass. Okay, and so these are the formulas. Rho of xy is the density function. Okay, so rho of xy is the density function. The mass is going to be the integral over the region where the object lies of the integral of the density function dA. The moment about the x-axis. Okay, so the moment about the x-axis is refers to how it kind of rotates about the x-axis, or kind of like if this was a weight applied here, then how much it would be forced to turn around the x-axis. Okay, so the x-axis is, so the moment about the x-axis is actually related to the y center of mass, and the moment about the y-axis, that's how much it's going to tend to rotate about the y-axis, and so that's related with the x-coordinate of the center of mass. Okay, and so these are formulas that you've seen before. Also, we have these joint probability distributions. And to be a joint probability distribution, the double integral has to be 1, because that's probabilities. All probabilities have to add up to 1. And the probability of getting a value in a certain region is going to be the integral over that region of the probability distribution function. And this right here is the expected x value. And this right here is the expected y value. Okay, what that means is if it's another word for the mean. Okay, the mean x values. Although this is from a population distribution, not a sample distribution. So, but yeah, expected value is kind of like saying the mean. So the mean x value. So if you sampled from the probability distribution an enormous number of times, then your mean would be close to the expected value. And the mean x value would be that, and the mean y value would be close to the expected y value. Something like that, okay? So let's go ahead and do some problems involving this. So the first one is to find the center of mass, or find the mass and center of mass of the lamina that occupies the region D and has the density function 4 times x plus y. So that's the density function, and this is the region right here. Okay, so first thing is we're going to figure out what the region is. It looks like 0, 0, and 0, 3 are in there. So here's 0, 0, and here's 3. Okay, and again, this is the x-axis. That's the y-axis. So you have those 2 points, and then you have 2, 1. So that's 2, 1 right there. Okay. So this right here is the region. Okay, so the mass is going to be the integral over that region times the density function of the density function times dx dy, right? Or dy dx, whichever one is better. Okay, so which should we integrate with in respect to first?
I would say Y.
Yes, Y is a good is the best option. Okay, because we can come up with the upper and lower boundaries. So what is the equation? So if we extended this lower boundary to a line, what would the equation of that line be?
It would be Y is equal to up 1 over 2. 1 over 2x.
Yes, x over 2. Okay, so that's going to be our lower limit right there. Okay, and then if we extended this line right here, what would that be?
Y is equal to negative, I don't know what that is, negative,
2 over 3
negative.
raised over n.
So from here to here, it goes down by 2 and across by 2.
Oh, just negative x.
Yeah, so the slope is negative x.
Negative x plus
And the
3.
y-intercept is 3. So negative x plus 3. So the upper limit is going to be negative x plus 3. Okay. Let me write it as 3 minus x, though, because that's just like... Okay, and then you're integrating the density function, which is 4x plus 4y. We're going to do y first. Okay, then we're going to do dx. And what's the limits on x?
Limit on x. 0 to 3.
Almost 0 to 2. So we're going to here. This is the last one right here. Okay. So each one of these x's, here represents a vertical line or strip or something, right?
Mm-hmm.
And you have them from 0 to 2. From outside there, they're not in outside 0 to 2. You're not getting vertical strips that are in the triangular region. They're in the lamina or triangular region. Okay, so that's the integral right there. And it turns out that this is really nasty. Extremely nasty. Okay, so check this out. So integrate with respect to y first. We got 4xy plus 2y squared. And you're going to evaluate that from x over 2 up to 3 minus x. Okay, so you have 4. So you're setting the y becomes 3 minus x here. Okay, so that's the upper limit, and then you're subtracting the lower limit from it. So putting in the x over 2s also. So you put x over 2 into here, you're gonna get
2x squared.
Yeah, 2x squared. And if you put an x over 2 in here, you're gonna get
Y squared. Oh, x squared.
yeah, x squared over 2, right?
Yeah.
Okay, so you have to expand all this out, and it's kind of nasty, but here's what you get. I'll just simplify it for you. You get negative 9x squared over 2 plus 18. So a lot of stuff cancels out, it turned out. Okay. Okay, and then you just integrate this, that's going to give you negative 3x cubed over 2 plus 18x. And then evaluate that from 0 to 2. So plug a 2 in here, and you're going to get negative 3 times 3 2's over just 1 2. So one of those is going to cancel. And then plus 18 times 2. So this is what? Negative 12 plus 36, which is 24. Okay, so the mass is 24. Okay, and then the next thing that you want is the center of mass. Okay, so for the center of mass, you have to calculate the moments. Okay, so let's start with the moment about the y-axis. And that one, fortunately, you can just copy down the same limits of integration. And the difference is, instead of integrating this, you're going to integrate x times that. Okay, so you multiply everything by x. That's 4x squared plus 4yx. Okay, now, because you're just multiplying by x, then it doesn't really affect the main parts of the integrating with respect to y. So that means that if we come down to here, then that means that all of this part right here is going to be real. All the stuff that we did in the camp on all this, everything and right here and all that, all the way down to here is going to be similar, except you're going to have a negative 9x cubed plus 18x. Okay, so except you're going to end up with that. Okay, so basically just multiply by x. That's just a little bit of a shortcut. Okay, and then we can continue on. Integrating this.
Negative 9x to the 4th divided by 8.
Yep.
Plus 18x squared divided by 2, so it'd be 9x squared.
Yep. And we're going from 0 to 2. Okay, so if you put a 2 in here, you're going to get 16 over 2. It's 9 times 2 is negative 18, so that's negative 18. Here, it's going to be 9 times 4, which is 36. So that's going to be 18. Okay, so that's the moment about the y-axis. Now, that means that the x-coordinate of center of mass is the 18 over 24, or 3/4. Okay. Okay, now unfortunately, now the next one is really nasty, and then we don't have enough space, so maybe we should just not do it. No, I'm just kidding. So the next one is we have to figure out the moment about the x-axis, and that's where you're going to multiply this by y. So that really messes up the y integration. That changes the y integration. You can't just copy that part down. So the moment about the x-axis So I have the same limits of integration, except now here, instead of multiplying by x, you're multiplying by y. So when you integrate this, you get the nasty stuff. So this is what, 2xy squared plus 4y cubed over 3, evaluated from y equals x over 2 to y equals 3 minus x. Okay, so you plug the upper limit in here. And in here. And subtract and plug the lower limit in. So x over 2 plugged into here is going to give you x cubed over 2. Subtract and plug the lower limit in here. And that's going to give you x cubed over 6. Okay. If you expand all these out, wait, I made a mistake. This is 3 minus x squared right there. Okay, so I already worked this out. If you expand everything out right here, then so expand that out, cancel everything that can be canceled. It turns out that you end up with this. Well, so I'm just gonna put like a bunch of dots there. Dot, dot, dot. Dot, dot, dot. Okay. So if you expand everything out, then it simplifies down to that. Okay, which means when you take the integral,
Negative 9x squared plus 36 divided by 18x. Oh, sorry, never mind. Yeah.
Yes. Evaluate from 0 to 2. And then you plug a 2 in, and that's going to give you negative 36. And then this is going to give you 36 times 2, which is 72, but then it's going to be 36. Okay, so the moment about the x-axis is 36, which means that the y-coordinate for center of mass is that moment divided by the mass, which is 24. So that's 3/2. Okay, so the center of mass, the x-coordinate, we previously know that the x-coordinate was 3/4, right? Yeah, so 3/4. That's from the previous page, and then this one's 3/2 from there. So that should be the center of mass. So 3/4, comma 3/2. Okay, so yeah, from here, that's 3/4, comma 3/2. So you write it down as a coordinate. Now, one thing that like if you're doing this on the exam, so you've noticed that there's a lot of room for mistakes, right? That there's a lot of room for making mistakes right here, right? So there's like lots of places literally where I could have made a mistake. And probably if you're just working, if I'm working through this, I'm going to make some mistakes right now. You guys know. And so you might make some mistakes if you're doing the exam. So, but one thing that you ought to do before you, once you get this answer here, before plugging that in, you should come back to here, to the picture, and see if it makes any sense. Okay, so here, our x coordinate for center of mass is 3/4, right? That lies about right here. Right there, 3/4. And so that makes a lot of sense because, you know, if we got something more than 1, you'd know that's wrong. If you got something that's negative, then you'd know that's wrong. And if you got something way over here, you would know that's wrong right away because it's got to be balancing the plate, right? Now there's this right here, the density is off, is kind of this 4x plus 4y, so it's kind of hard to tell what the density to do. But it sounds like, but what this does is it says the density is going to be higher when you're further away from here, okay? So 3/4 makes sense, you know, that if this is a uniform plate, the 3/4 would probably not balance it, it'd probably be heavy over here. But because of the density, it's right there. And then the y coordinate is 3/2, which is like 1.5. So here's 1, 1.5 is, that's about halfway between 0 and 3, right? So 1.5 would be right there. So that looks like, so right there for center mass looks like about right. Let's mark it down. So right there, we're center mass, we're looking about right there. Which sounds about right, because the density means that it's more dense over here. That's why it's not. I mean, if it was just like a, if it was a uniform plate, then the density would probably be over here. The center mass would probably be over here somewhere, maybe right there. Okay, but since it's more heavy over here with larger values of x and y, then it's moved it a bit. Okay, so. In other words, before you put this answer in, check and see if it makes sense. Okay, so number 2, the boundary of a lemma consists of a semicircle, of 2 semicircles, together with the portions of the x-axis that join them. Okay, so this one right here is also, it could also be written like this. And this one is x squared plus y squared equals 4. So this is really the circle of center with center 0 radius 1. This is a circle of center 0 radius 4. So the region is going to look something like this. So if this is the xy axis, then if this is 1, and that's going to be the top part of, that's going to be this part here. And then this one will be radius 2. And it says the x-axis. Okay. So it's going to be this region here is what we're looking at. Now, actually, this is not actually completely equivalent to this, because this is just the upper half of that. Because if you take this and solve for y, you get plus or minus, right? And the plus is the upper part, and the minus is the lower part. So it's only the upper part, and then part of the x-axis. So these are also boundaries also on our region. Okay. Okay, so to find the center of mass, if the density at any point is inversely proportional to its distance from the origin. Okay, that means that the density is going to be, it's inversely proportional to the distance. Now the distance from the origin is also r from polar coordinates, so it's k over r. So this problem we're actually going to use our polar coordinates skills. Okay, and then that's really like r equals 2, and this is r equals 1. Okay, so let's go ahead and set the integral up. So we're integrating over a region, and we got a rho. So first of all, we want to find the mass, right? Rho dA. Okay. So so rho is k over r, right? And then dA is r dr d theta. I do the easy part. Okay, so what's the limits on r now? Anybody want to take a guess?
I mean, oh shoot. Is it r equals?
Wait, I made a mistake here. I don't know why I've changed this 16 to a 4. This is really bad. This is 16. That means r is 4. This is actually 1 and that's 4. Now my graph is off. Oops. Okay, so go ahead. What do you say? What do you think the limits are?
Oh, for r?
Yep.
Is it from 1 to 4?
Exactly. 1 to 4. So from anywhere radiating out from the center, it's going to be that. That part from 1 to 4. Anywhere, any of these places radiating out from the center, 1 to 4. And then theta? Okay, this right here?
Negative 1 to 1?
No, theta. What angle is this? Going out this way.
Oh, 180.
So that angle is 0, and this angle is, and as you go up this way on angles,
Oh, pi.
yeah, this is pi. So 0 to pi. Okay, so this is interesting. Look, check this out. The r's cancel. You just have k dr theta. So you just have a constant. So if that's the case, then the integrals become the integral just becomes this. So that's 3 pi k. Okay, so the mass is just 3 pi k. Now, unfortunately, it doesn't say I find the mass, so blah. We just have to find the center of mass. But you got to find the mass to find the center of mass, so that's kind of helpful. So now, what we need to do is find the moment about the x-axis. Wait. One thing you can, well, let me just say something really quickly before I do that. And that is, what do you guys think the center of mass in the x direction is?
Shouldn't it just be 0?
Yes, it's going to be 0 because this is just, because there's this part and there's that part, right? And they're both kind of symmetrical with each other. The density could throw you off, but the density is symmetrical, right? The density is symmetrical right here. So like point over here is just as dense as this point. That point is just as dense as that point. So there's only one correspondence between the densities and everything. So the center of mass x coordinate is 0. Okay, so that's good. So that means you only have to find the y coordinate. So so we integrate over the same region, and instead of so we're going to have this right here. So we still have the dA part, and we still have the rho part. But for this one, we need to put a y, right? But y is r sine theta. Okay, so that's our y part. R sine theta. And so these r's cancel, or maybe those r's cancel, but anyways, we get an r, we have an r sine theta dr d theta. Okay, so integrate in r, and oh, I forgot. Oh yeah, there's a k. There's a k right there. It's just a constant, so I can pull it all the way out there. Okay, so integrating in r, we get r squared sine theta all over 2. And that goes from r equals 1 to r equals 4. Okay, so if you put a 4 in here, you get 16, and you put a 1 in, you get 1. So 16 minus 1, that's 15k over 2. And then you're integrating sine theta from 0 to pi. And the integral of sine theta?
Is this cosine theta?
Is it cosine theta?
Yeah.
Negative
Negative
cosine.
cosine theta.
Yeah. Okay, so if you put in a pi, you get cosine of pi is -1. So that's actually, and then you have minus a -1. Okay, so this is actually 2 then. And then that cancels with that 2. So you get 15k. Okay, so your moment about the x-axis is 15k, which means that your y-coordinate of center of mass is 15k divided by 3 pi k. K's cancel, and this reduces to 5 over pi. So that means that their center mass is 0, 5 over pi. And then you can think, yeah, you can also think, does that make sense? And maybe take a calculator and figure out where 5 over pi is. It's probably somewhere right here. It's probably somewhere right here. But then again, I really messed this up. This should really go up. This should really go up to 4. I really should have made it bigger. But I don't know. I saw 16 and I thought 4. I thought I'd put a 4 there instead of a 16. So, oh well, it didn't happen. So anyways, the center of mass is like somewhere around right here, maybe. Right there. Up here. Why does it? Okay. So let's go on to the third and final problem. So this is dealing with probability density functions. And do you guys remember what the first thing I said about, in order to be a probability density function, what do you need?
Something has to equal to 1.
Yes. So you actually need 2 things. It needs to be positive, or at least greater than or equal to 0 everywhere. Not positive. It has to be non-negative. It can't be negative anymore. And the integral over everything that has to be 1. So to determine if it's a density function, this is always positive, right? Greater than or equal to 0. This is 0 right here. So we take the integral over all of the function. And because it's 0 when you're not in this right here, that means that we can just go 0 to infinity. 0 to infinity of 0.1 e to the negative 0.5x minus 0.2y. And then we can go dx dy. And just do that. Okay, and that's supposed to be 1. But let's see, what is it 1? So let's see. If we integrate this with respect to x, then we're gonna get a negative 0.5 come out, right? So 0.1 divided by 0.5 is 0.2. This can be negative 0.2 e to the negative 0.5x minus 0.2y. And that goes from x equals 0 up to infinity. Well, it's just kind of weird notation, but whatever. Okay, so if you put an infinity in here, then that's going to be 0. That goes to 0. As x goes to infinity, this goes to 0. So then you're subtracting with just a 0. So you put a 0 in here, and you're going to just get, so you subtract, and that wipes out that negative, so you get 0.2 e to the negative 0.2y. That's plugging a 0 in for x. Subtracting and plugging a 0 in for x. Okay? dy. And then you integrate this, and you're going to get negative e to the negative 0.2y. And that's also going from 0 to infinity. So that's going to, when you're taking the limit as y goes to infinity is 0. And then plugging in a 0 into here gives you negative 1. So that's 1. So the answer there is yes. Okay, so the second part, find the probability that y is greater than or equal to 3. So what you do there is on the y part, so this is the y part of the integral, you have that go from 3 to infinity instead of 0 to infinity. And that's the probability that y is greater than or equal to 3. X is still going to go from 0 to infinity. Okay, so because x still goes from 0 to infinity, that means that this part right here is going to still play out the same. And you'll get the same, you'll get this, you'll basically get all the way to here. But you'll go from 3 to infinity. Instead of 0, you'll go from 3 to infinity. But everything else, this will all play out the same. Okay, and then so again, you'll get 0. This is going to be the same. But then here, instead of plugging a 0 in here, you're plugging in a 3. So that's negative e to the negative, let's see, 3 times 0.2 is 0.6. E to the negative 0.6. e to the negative 0.6, which is approximately 0.5488. Okay, so that's the answer to part B, 0.5488. Okay, part C. This one, you have x less than or equal to 4 or y less than or equal to 4. So what's going to happen there is you're going to go from 0 to 4, and then y is going to go from 0 to 3. But you'll have the same thing.
Brother Hurst, you wouldn't use negative infinity for the
For what?
for the lower terms of integration?
Right here?
No, on the one you're doing right now. You went from 0 to 3 and 0 to 4, but if it's less than 4, you wouldn't do negative infinity?
No, because the reason is right here that when x is greater than or equal to 0, y is greater than or equal to 0, it's this. But if x is negative or y is negative, then it's just 0.
Oh, okay, got it.
And that's the same reason as why we started from 0 to infinity here as well. Okay. So there's this one here. So you got to integrate that. Ouch. It looks like we don't have enough time for that, but I'll tell you what, I figured out what it is. So if you go through all the steps and everything, you're going to get it is kind of nasty, but I got approximately, well, I got on this part right here, I ended up with that. Evaluated from 0 to 3. Okay, that's after integrating with respect to y. That's after integrating with respect to x, plugging in the upper and the lower limits 0 to 4, and then integrating with respect to y. And then the limits are going to be 0 and 3. And in the end, I got 0.3901 for part C. Okay, then part D was to find the expected value of x. And for the expected value of x, what you do, you're still gonna integrate from 0 to infinity, but you're gonna multiply by x. So you get that. Okay, so 0.1 is the same as 1/10. I just pulled that out there. You don't have to do that, right? And then this right here, if you integrate it, you get something like this. It's not that nice. So here's the tricky part right here. As x goes to infinity, this is x going to infinity. As x goes to infinity, this goes to negative infinity, right? E to the negative infinity is 0. But this x right here is infinity. Okay. However, this overpowers it. So this goes to 0 faster than x goes, much faster than x goes to infinity here. So that means the whole thing goes to 0. The whole thing is 0. That means the upper limit just completely gone. And then for the lower limit, this part goes away. So you just end up with this. You just get the lower limit. You just get 4e to the negative 0.2y. So the only thing that survives is this 4 here, which is on the lower limit, so the negative gets flipped. And then if you integrate that, you have 4/10, right? If you integrate this, you get another negative 0.2 coming out right there. And 10 times 0.2 is just 2. And that's the lower limit. So upper limit is 0. Lower limit is just this. Okay, so 2 is the answer for part C. And part D. I'm sorry. 2 is the answer for part D. Wait a minute. Okay, it is part C. Oh well. And this is the second part of part C. So here, instead of an X, you have a Y. And the integration for, with respect to X goes just as we did before in this case. You end up with this. And if you integrate this one, you get negative 5y minus 25 e to the negative 0.2y evaluated from 0 to infinity. And again, the upper limit, when you plug in y equals infinity, then this is all 0. Even though this is infinity, the whole thing is 0. Because this goes to 0 much faster. And so you only have plugging in the 0, which makes that go to 0. So you have what you have negative 0.2 times negative 25, which is 5. Okay, so the expected value of y is 5. Now here, you can also somewhat check this, although it's a bit harder. I guess you could say, well, we got positive numbers for the expected value, so that's good. If we got negative numbers, then we'd know that's not right. So we got positive numbers, so that's good.